Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Meredith Chaiken, Joel, and Seth's brother Joel. We are here to show you how to approach SAT math questions. Today is a special treat. Someone emailed us a SAT math question. You can tell it probably is from an SAT test because of that distinctive typeface that the SAT uses. So without further ado, let us get to this question. We always like it when people email us SAT math questions. So here we go. Multiple choice question. In the complex number system, what is the value of the expression above? So then essentially you just want to evaluate what I squared and negative I squared are. Oh, this is a squared, by the way. It's hard to read. So
I'll write it really neat.
okay. So they even nice enough to tell you what the definition is. It's sort of like a definition there. I is defined as a square root of negative 1. If I is defined as a square root of negative 1, then I squared is equal to negative 1. That's very useful to have, so that's negative 1. Now here is interesting. It's negative I squared. So one can just write negative I times negative I. Which the way I like to do it is, if you're not sure what to do, you could always put a 1 in here. This is negative 1 times I times negative 1 times I. The negative 1 times the negative 1 is a positive 1. I times I is what we did before. That's a I squared, and that's plus 1 times negative 1, which makes negative 1. So you have negative 1 plus negative 1, which makes negative 2. And you have to be aware of integer arithmetic with negative signs. Right, yeah. So it looks like the answer is negative 2. What do you think, Seth?
I agree.
Yeah, how would you approach dealing with this negative 1 squared thing? Negative
Well, having done problems with complex numbers a long time, I just know that negative I squared is negative 1.
Yeah, but that's
I
not going to
just
help.
know. Yeah, I memorized. Basically, I memorized it from experience that I squared is negative 1, and negative I squared is also negative 1.
I see. So you've seen
It's like how I know 2 times 2 is 4,
right,
or 2 times 3 is 5.
but most people studying for the
Well,
SAT.
you asked me.
Oh, right. No, okay. Oh, right. That's true. It is my fault.
Yeah,
I
yeah,
did
yeah.
ask you. Okay. Well, putting yourself in the shoes of a 10th, 10th or 11th grader in the United States, how do you...
My feet would hurt.
What? That would hurt.
My feet would hurt.
Your feet would hurt. Yeah. Well, it depends on the person, whether they have big shoes, whether feet or not. But seriously, do you have any other methods, approaches to do that other than what I did?
No.
No. The other thing to notice is you could do this negative I squared. You could put a negative 1 I squared, and then you distribute the square to each one, which is essentially what I did. Right? I mean, this is essentially what I did.
Yeah.
Right? Yeah, okay.
Right.
So that's it, really. I mean, they're nice enough to give you the definition of I. And hopefully, most people studying for the SAT will have had some exposure to complex numbers in their school. But if not, they're nice enough to give this to you. And when you're studying for the SAT, you should definitely study complex numbers. It's part of Khan. Khan Academy has a section on complex numbers. And it's something that...
I'll say I'll tell everybody what the basic rule is.
Go ahead.
Basic rule is that you simplify using all the laws of arithmetic that apply to ordinary numbers. You simplify until and you simplify and you use simplify using I as if it were a variable. Okay, so, and then at the end, when all of the occurrences of I have the form of powers of I, like I squared, I cubed, even negative powers of I. Well, if you have a negative power of I, like I to the negative 2. Well, general rule, is that n to negative power is equal to the reciprocal of n to the positive version. So I to the minus 2 is 1 over I squared. So you bring everything down so that the only appearances of I are I by itself, I squared, maybe I cubed. And then at the very last step, wherever you see an I, you leave it the way it is. Whenever you see an I squared, you replace it by minus 1.
Right.
So if you have an I cubed, you simplify that to I times I squared, and then use the final rule that is to replace I squared by minus 1. And then apply ordinary rules of arithmetic that negative 1 times anything is the negative of the anything. And then it all boils down, well, if you have an expression involving addition, subtraction, and multiplication, no division, you'll end up with, things something like this. Numbers, plus and minuses and all that, you replace all the I squareds by minus 1. In higher powers, you just reduce the powers by picking off squares of I, replacing them to minus 1. And when all is said and done, you're going to get some expression times I plus some expression that expresses an ordinary, real number in arithmetic. And that's the simplest form.
Right. Okay.
So the rule is you do not use any rules beyond the ones you already are familiar with from real arithmetic. But except then you add one more rule, which is to reduce I squared to minus 1.
That's a really good approach. That's a really, really good approach. This way, you don't get intimidated by anything with the eyes. You just do everything the normal way, and then at the very end, replace. Okay, so today's Throwback Thursday, which means we go back and, that looks like really hot tea. Today's Throwback Thursday, where we go back to a test that predates the 2016 SAT, when the test became more of a test about what you know in school rather than reasoning. But it's always nice to see what the test looked like about 20 years ago. So we will visit a question. We will first clear all drawings, and we will scroll over here. And this is our SAT math question of the day for Throwback Thursday. Here we have a test from probably about 20 years ago. It's an official SAT question, and we need to see all the little rings, don't we? Okay, let's go into annotation mode. I really haven't looked at it much. Seth, I don't think, hasn't looked at it either. And let's go. Question from around 20 years ago, maybe more, 25 years ago. Okay. The figure above shows the remaining pieces of a paper chain from which a section has been removed. The first link of the original chain was red. Oh, they have an R there. That's nice. And the colors of the links formed a repeating pattern. R, yellow, G, white, blue, from left to right. Which of the following could be the number of links in the section that was removed? Oh, looks like a bit of what I would call a number theory problem here.
Could be.
Having to do with
Ah,
integers, something to do with. Well, anyway, people should stop it, try it, come back if you're interested in doing a Throwback Thursday question. This the question like this doesn't seem to be on the modern tests, but something to do with not number theory thing, right? It has to be an integer. What is this?
yeah.
How many
Oh, wow.
cycles are there?
Okay.
1, 2, 3,
Yeah.
4, 5. So it goes every 5, right?
Yeah, yeah. So RYG. Yeah,
This is
so
a
the patterns
2.
okay, they actually tell you the pattern.
Yeah.
You know, so the pat is they tell you the pattern right here. Well, the pattern is given to you in the problem.
Right.
So the pattern, I'll write it down here, is RYG, RYG, W, and B.
Mm.
And
Yeah.
it's length of 5.
Length of 5. That's
Okay.
critical.
Yeah, and so every gap, every gap. Well, so let's figure it out. Let's figure it out.
Right.
Let's figure it out.
Every gap.
This is what I do is approach it very directly.
Yeah.
I start from the beginning, and I see it starts with red, just like they said. So I said red, RYGWB. Okay. Then I continue RYG, and after the G there's a W. So the gap is going to begin with a W.
Right.
Now, what about the end of the gap? Well, there's a blue here. I'd read it backwards. Look at that. They started it very conveniently with a B at the end. So I just go backwards. BWGY, BWGY, BWGYR. So the gap ends with an R.
Absolutely. The gap ends with a
Okay,
1.
so now
Yes.
what could be between a W and an R? And this is how I'll do it. I'm not using any sophisticated thinking, any sophisticated machinery of mathematics. I'm thinking that after the W, I look up at the pattern, there must be a B. Right?
Right.
After the B, after the B, there must be an R. So I write an R.
Right there. Yeah.
And
right
now I got lucky. I ended up at the beginning of the pattern. So what happens next? Must be here's the R. So after the R, there's a Y, G, W, B. And after a B, there's an R. So I put parentheses around this section, because this section might be repeated.
Right.
R, Y, G, W, B. Right? And then after the B, well, the pattern, okay, I figured out that the gap begins with an R. So this thing is going to have to, after the last repeated section, there must be an R.
Oh,
Okay, so there's
R's
the R.
got to be a multiple of 5.
And so, they
5,
ask,
6.
what is the number of links? So what I see is there must be a blue at the beginning of the gap, which I'll number 1 because I want to count them. There must be an R at the end of the gap, so I use my counting fingers.
Yeah, a W at the beginning of the gap.
1 plus 1, 2 makes a 2. And then what might be there in the middle? Any number of groups of 5. So it's 5 times any number. And so I look at these, and so now I start using a more advanced concept of math. Whatever number is here, if you would divide it by 5, what you would want to get is a remainder of 2. So 61 divided by 5, well, 5 goes into 60 evenly. I don't care how many, it's just 12, and the remainder is 1. So the pattern is, well, since 60 is divisible by 5, I can see immediately that the pattern for numbers that are a little bit more than 60 and are divisible and have the property divided by 5, you get 2 as a remainder, is 62. 62. That's the only choice they give, and that's the answer I give.
Right, because I think when I spoke earlier in the middle, I was wrong. This is the number that has to be divisible by. This is the number that has to be divisible by 5. The ending number, the blue has to be divisible by 5. 1, 2, 3, 4, 5, 6, 6,
Wow.
7, 8, 9, 10. Yeah. The blue number has to be divisible by 5, right?
I wouldn't say that. No. Oh. So you're counting from the left-hand side.
The blue number,
Yeah.
the blue ring has to be the number of the blue ring.
Oh, okay. That's a different way to think
5.
about it. Yeah.
Has
So
to be
you
divisible
number
by
the
5.
rings.
Yeah,
Okay, that's
yeah.
a different way. Yeah. That was some people might think of it that way.
Let's see. So
Yeah.
if you number the rings, that number has to be divisible by 5.
The blue ring must be in a position that's divisible by 5 when you number the rings beginning with 1 at the left-hand side.
Right. Right. So how does that force you to have 62 though?
Well, you figure it out. That was your idea to look at it this way. I'm not looking at it this way.
Okay, you're challenging me. Okay. Well, David, putting me
Come
on.
on, you could do it.
Yeah, I could do it. 1, 2. I've never been that great with these types of problems, I must say. So, gonna be patient with me. 1, 2, 3, 4, 5. I'm also not great thinking on my feet. 1, 2, 3, 4, 5. So you need. See, I thought originally, and I was wrong. I thought these gaps would have to be a multiple of 3, but I'm wrong. That's actually not a multiple of 3, is it? So I was wrong there, which is good because there are 2 numbers that are multiples of 3. So then I said, well, that can't be unique. So 1, 2, 3, 4, 5. I would do a few more examples. I like brute force. Okay, so then let's consider this one. This one here has a length of 3, right? Okay, here's the smallest possible gap is 3. Okay. That's right. Yeah, the smallest possible gap is 3. So then,
Is it?
3.
Well, there's a reason why the possible gap is 3 because, after G, there must be a W, and the W is not a Y. So there must be a W. That's 1.
Yeah.
After the W, there must be a B.
That's right.
Well, B is not a Y, so there must be a 2.
Right.
And then after the G, there must be a W. After the W, there must be a B.
Right.
And then after the B, there must be an R.
Right. So that means there must be 2.
And then there could be a yellow.
5N.
So it's 3. I think maybe I made a mistake.
Maybe you did.
I think I did.
I think you did.
Yeah.
You did. Because look, it's 2 plus now Seth's insight is brilliant.
Uh-oh.
There has to be a 5.
I think I made a mistake.
And then you need little R. Little red comes in.
Yeah.
Wow.
Or maybe it's 63.
Yeah. And it is a multiple of
Yeah.
three. And it is
Yeah.
a multiple.
The logic I use, I think is right. So let me redo my logic. My logic was the gap must start with a W.
Right.
Right. It must start with a W. Uh, so why do so after W there must be a blue, and after the blue there must be a red,
Right.
and after the red there must be a yeah. After the red there must after the red well at the red the pattern repeats, but so after the blue there must be a red, right? And then after the red, there could be the yeah, it has to end in a red.
Has to
I said
end
it
in
has to
red. Has to end in
yeah,
red.
so that's why I put an R here. I counted one for the R. Oh, sorry, I counted two for the R. I counted one for the blue, and I forgot to count the W. That's my
Really?
yeah,
Wow.
that is the problem. I
Wow.
made a mistake.
Wow. Wow.
So I should have said in the gap. In the gap, we must start with a W, and the W is not a Y. So my finger counting one.
Mm.
After the W, there must be a B. So I draw the B, and the B is not a Y either. So my finger counting gives me two. After a B, there must be a red. And a red is not equal to a Y, so there must be a red. That's three. After a red, there must be a yellow and a Y, and a Y is there. Okay? So I should have counted three things: one, two, three. And then in between, there's a sequence of what comes after R's. And the sequence that comes after R's are yellow, green, one yellow, two green, three white, four blue, five red.
Right. Yeah. Well,
So I made a mistake about the two wrong. And so the number that's possible for every number that's possible for the answer, the whole thing is 3 plus
right.
5 times n.
Yeah.
And of course, n has to be at least one,
At least one, right?
because there are more than 5 rings.
Right.
So we can't have just if they gave you a 3 here, that certainly would be wrong.
Yeah.
So, however, they
didn't. Yeah.
So of these, the only one that's has the form a multiple of 5 plus 3.
Yeah.
Is 63.
I mean,
See that counting? I got messed up, and that's part of the issue. Why these old SAT questions are so hard. There were several steps of reasoning and counting.
Yeah.
You had to count. You had to count the length of what's called the period.
Right.
This is what we say is that the rule for the chain of colored paper rings, the rule is that that after a starting after a prefix or suffix, the pattern is periodic. It repeats. And the number 5 is called the length of the period. So they don't tell you it's 5. So you have to count to get the 5. And then you have to count, how many additional rings there must be so that the gap is as the right starting and ending rings, and then as the right extra rings, for which the rings in between the extra rings are multiples of 5.
Yeah, that's
And so
why.
so he had a different count to end up with 3.
Well, that's why I like to see it here.
Yeah,
That's why it really says it. Doesn't it really say it right here? That you have to have 2, and then you have a gap of 5s, a number of 5s, and then you have to have the extra 1, and then that's
yeah,
what it
yeah,
says.
yeah,
Yeah, yeah,
yeah.
yeah, yeah. So
So
unfortunately, on the SAT, I'm
yeah.
not
So
going to have
the thing is,
time.
with the idea of the period is that for the middle of the train, they happen to say that the chain begins with a red, uh, and they told you it ends with a blue. So the chain itself consists of repetitions of the period they gave, right?
Right.
Uh,
I'm just trying to look for the answer.
right. Yeah, yeah.
No,
So, but the gap is not simply a repetition of the period they gave. So, what I was thinking of the period they gave, uh, should actually be considered written in a circle. I'm going to write it as a circle. I'll start with R at the top, and then going around the circle, I have Y, G,
by the way, I
W,
just checked the answer in the book. It is 63. Okay, it is 63
6
because we
W,
are
and
falling over
B.
ourselves today. The official
Yeah.
answer is 63 of the book. These books, believe it or not, they do
Oh,
not
hey, Joel,
explain.
are you please respond to my comment that you could view the rule for the coloring is a circular rule.
Okay. Um. Yeah.
Okay.
Right.
So the rule is if you start anywhere in the chain, like here, W, you could read off the letters after the W by starting here. W is a W, and then blue, red, Y, G, W, blue,
Right.
red, Y, G, W.
Right. Yeah.
Okay.
Right.
Yeah. Yeah.
Yeah, that's a good way of doing it too. Yeah. 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 It's a circular. Right.
Yeah.
Yeah.
So that's a characteristic of periodic repetitions.
Right.
That the period could be started anywhere.
Yeah.
And then the whole chain might start anywhere. You could start the period anywhere. Yeah.
This is also a really challenging question because look, in the old SAT they had a lot of sections. Oh, they had so many sections. This is section 7 and a late question in section 7 because the sections are fairly small.
Yeah.
So by this time, your brain is really fried, and then you get this thing. Yeah. So I don't know. People should be happy. If I were people, I would be happy not to be taking the older SAT because this is a tough question, particularly given late in the test.
Yeah.
Okay.
It's fun. It's fun to get hold of the questions and do them for fun.
Yeah. I mean, you can buy these books on eBay. These things, but notice they don't give the answers. No, they give the answers. They don't give the explanations. So, okay, great. So Seth made a little mistake there. My little view here going slowly helped a little there. But I also used Seth's idea. So I'm coming in with the way I did it. I did Seth's idea that there's a 5. You have to have these chunks of 5, these quantum of 5, 5 chunk, 5 chunk, 5 chunk, in order to get back to the red. So, okay, I guess let's try for tomorrow. We've just closed this Throwback Thursday. Please like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestionoftheday@gmail.com. And please do what a person just recently did, which is email us a SAT question, and we'd be more than happy to go into it and look at it from different perspectives. That's a good approach to problem solving, to look at problems from different perspectives. Okay, great. Okay, everyone, have a great day. Bye-bye.